In class, today we are looking at section 613. So what we're doing today is we're trying to figure out when we should be using factoring and when we should be completing the square to graph. So we've got lots of different graphing methods. So let's think about how factoring is when we were trying to write it in this form, like y equals a times x minus p times x minus q. So because it was easy to factor, we went ahead and factored it, and then we used our x-intercepts. So when is it factorable? Not sure. You could always check the discriminant. That's b squared minus 4ac. And we can talk more about that later. And maybe if there's a leading coefficient other than 1. So if it's going to be difficult to work with. Completing the square is when it's not factorable and when your linear term is an even number. Those are two really important things. And then for us this year also when your leading coefficient is 1. So that means when you have like a 1x squared, y just equals x squared. And then basically a table is when neither of those will work. Remember, we could also just have vertex form to start with. So that's the other one to watch out for. Like if it's vertex form, we don't have to do any work. So remember, completing the squares when we add that special number where we take our middle term, our linear term, we divide by 2, we square it, we look at that coefficient there. We'll go through the process here in a second. So kind of looking through these problems here. The first thing I would do is check to see, do we have any that are already in vertex form? And I don't see any parentheses, right? The parentheses are kind of a dead giveaway. Vertex form is y equals the quantity x minus h squared plus k. But what we do see, this problem right below where I'm writing right now, I can see it's just my x squared graph and then down 6. So it's almost like having an x minus 0 squared minus 6. So my vertex is going to be 0, negative 6. So like I said, it's like I literally took my graph of x squared and I moved it down 6 units. So I'm going to go ahead and graph that one right away. So that's going to be definitely the easiest one to graph here. So I start at 0, negative 6. My graphing pattern's 1, 3, 5, 7. So I'm going to quickly get some points on here. All right, now looking at what I've got left, number 1, I don't think it's factorable. When I think about what multiplies to make 11 and adds to make 4, it's just not going to work. So since it's not factorable and my middle term is even, that means that I could go ahead, not factorable, and then this guy is even. It's my linear term. It's the one that's multiplied by x. Often when we write quadratics, it's the middle term. It wouldn't have to be the middle term, right? But that's usually where we're finding it. So that's when we're going to complete the square. So to go ahead and complete the square, I want to start out by writing y equals, I'm giving myself lots of space, x squared minus 4x plus, and then I have to find that magic number that completes the square. So to do that, I take my negative 4, I take that middle coefficient, the linear coefficient, the x coefficient, I have to take that and divide by 2 and then square it. So negative 4 divided by 2 is negative 2, squared is a positive 4, so I want to add 4. If I add 4, I also have to subtract it because I'm offsetting that 4. So plus 4 minus 4 makes a 0. That means I didn't change anything in my original problem, but then I also had a plus 11 here. So then we're going to take these first 3 and we're going to factor. We'll take the last 2 and combine. So y equals the quantity x minus 2 squared and then plus 7. So let's go ahead and graph. We're going to start at 2, 7 as our vertex, and then I can't really fit very many points on here. I guess I could go off my graph a little bit. So our other methods, we're trying to use a method for each of these right now and just kind of show what this looks like. Our other methods are making a table and factoring. So we did our vertex form to start with. we did complete the square, which also uses vertex form. But we have not tried factoring and using our intercepts yet. And this problem right below where we were at on number 2, I notice I can divide all of them by 3. So I don't know if that's really going to help and if it's going to make the whole thing factorable, but it would definitely be a start. So let's divide 3 out of everything. So we have 3 times the quantity x squared minus 6 divided by 3 is 2x minus 45 divided by 3 is 15. So essentially I've divided 3 out of all of those. And then I feel like this one's going to definitely be factorable. So what multiplies to make 15, negative 15, but adds to make a negative 2, and that's going to be 5 and 3. And let's see, I would need the 5 to be negative and the 3 to be positive. So I can tell right away that my x-intercepts are going to be 5, 0 and negative 3, 0. So remember, those come from right here, right? If I'm making this equal to 0 and I'm solving it, if x minus 5 equals 0, then x must be a positive 5. It changes the sign. But if x plus 3 equals 0, my x must be negative 3. So that's solving with zero product property. So let's go ahead and plot those intercepts. So 5, 0, negative 3, 0. And we know that the x in the middle, the average one, is going to be like, that's where our vertex would be, because we know that parabolas are symmetrical. So I could look at this and find the middle, or I could take 5 and negative 3 and add them together and divide by 2 and find the middle. But I can tell my middle would be like right over in here. So when my x equals negative 1, or sorry, positive 1. So x equals 1 is going to be my x value at the vertex. To find my y, I need to go back and substitute x. So I'm going to use my factored form. So 3 times, I'm going to use this one that I have highlighted right here. I think it's the easiest form to work with. So 3 times 1 minus 5 times 1 plus 3. So I'm substituting in a value for x and I'm solving for y. So this gives us 3 times negative 4 times positive 4. That's going to be a really big number. So 3 times negative 4 is negative 12, times 4 is a negative 48. This is kind of crazy. So we're going to do our best to make sure on a test or quiz you never have a crazy value like this, right? But I'm just going to pretend 1 negative 48 is way down here, but it's not, right? I'm graphing way off the page. But it makes sense. If we think about how far apart our x-intercepts are, and then having this 3 graphing pattern here, that would mean 3 times your normal 1, 3, 5, 7. It makes sense that this is going to be some point that's crazy low on the graph. Again, this isn't even to scale. This would be like maybe a negative 20 right here. We need it to be at negative 40. But again, we'll do our best to not have a problem like this on a test or quiz. So this one was factoring. That was our next method. So I'm really thinking this last one is going to be a table. So let's go ahead and take a look at the discriminant. The discriminant is b squared minus 4ac. And if the discriminant is 0 or a perfect square, it tells us that we have something factorable. So our a is 2, our b is 4, our c is 9. So b squared would be 4 squared minus 4 times 2 times 9. That is 16 minus, let's see, 4 times 2 is 8 times 9 is 72. It doesn't even matter, right? It's going to be negative. That tells me it's not even going to have any x-intercepts. It's not going to cross my x-axis because I'm going to get a negative number. So it's definitely not factorable. So since it's not factorable, I'm going to go ahead and set up a table. And I'm not really sure what values to use to capture that vertex. So I'm just going to use my old standbys, negative 2, negative 1, 0, 1, 2. And we'll see how it goes. So for this, I'd probably use a calculator. So first I would figure out my y by doing 2 times negative 2 squared plus 4 times negative 2 plus 9. When I plug this into a calculator, when I'm squaring the 2, a lot of times I don't even put in my negative because it's a lot more work to add in that negative sign, and I know when I'm squaring I'm making it positive anyway. So that's kind of a trick to watch out for. When I substitute that in, I get 9. And then we could just erase the negative 2 here and put in a negative 1. That's another thing I like to do. Write it on my paper once and keep substituting. When I plug in negative 1, I get positive 7. 0 is real easy, right? When we plug in 0 for our x, then pretty much everything is just going to zero out except the 9. And this is good. So I can see like symmetry now, right? If I see symmetry, that tells me that I am getting a parabola, and that this one right here is going to be my vertex. That's what that tells me. So let's try one more point just to get a better idea of this graph. And if I put in 1 here and here, so 2 times 1 is 2 plus 4 plus 9, that's going to be 15. So at this point, I'm not even going to calculate what happens when x is 2. It's going to be a big number. I erased a little more than I planned on there. So we're not going to do that one. But I would know that I would have symmetry over here, and I could squeeze in a -3 and a 15 as well if I wanted to, even though that's just a little bit too much to graph. So let's go ahead and graph what we have. So -1 up 7, 0 is up 9. This one's here because it's symmetrical. And we've got our parabola. So this is just making a table. So if all else fails and you have some kind of weird, unfamiliar graph, you can always make a table. So hopefully this clears up our different kinds of graphing. I like that we have a day to just spend on this and spend on comparing them. Sometimes we're going to tell you to use a specific method, but sometimes we really want you to figure out which would be the best way to graph. So vertex form I think is always our favorite, but factoring is not bad. Making a table is not our favorite at all, but it's still doable. So don't forget about those options. As always, have a good day, and make sure if you have questions, you ask.